Brake fluid is a crucial component of any hydraulic brake system. It's used to transfer the force from the master cylinder to the wheel cylinders and calipers without loss. It can do this because liquids are not compressible. Most brake fluids used today are glycol ether based, with some mineral oil and silicon-based fluids also available. They must all meet certain requirements defined by standards set by engineering organisations or local government equivalents. Most commonly used are the DOT or SAE ratings that indicate the nature, blend and performance characteristics of that type of brake fluid. DOT is an abbreviation for the Department of Transportation, which is an American federal organisation. The DOT sets safety standards similar to the JIS in Japan or DIN in Germany. The higher the DOT number does not equate to the higher the brake fluid performance. This number categorises the fluids by its various uses. When selecting brake fluid for a vehicle, we should always refer to the manufacturer's specifications for the DOT and SAE rating. Brake fluid is also formulated to perform various functions, which include high boiling points, low viscosity, resistance to corrosion, and be compatible with a range of brake system materials. Brake fluid is subjected to very high temperatures due to the amount of heat created between the brake pads and rotor. For this reason alone, brake fluid must have an extremely high boiling point, preventing vaporisation. If the boiling point is too low, the vapour bubbles created during these extreme temperatures are very easily compressed. As pressure is applied to the brake fluid in the master cylinder, it will compress the vapour before moving the fluid through the system and applying the brakes. Most brake fluids are hygroscopic, which means they are able to absorb moisture from the atmosphere, effectively lowering their boiling point. That's why it's very important to ensure all brake fluid containers and vehicle reservoirs are sealed from the atmosphere at all times. Brake fluids are rated with dry and wet boiling points. The dry boiling point of brake fluid refers to the boiling temperature of new fluid from an unopened container, whereas the wet boiling point is defined as the temperature DOT brake fluid will begin to boil after it has absorbed 3.7% water by volume. This table shows the dry and wet boiling points of different categories of brake fluid. The most commonly used fluids in passenger vehicles are DOT3 and 4. DOT3 has a dry boiling point of 205 degrees and a wet boiling point of 140 degrees Celsius. DOT4 has a dry boiling point of 230 degrees with a wet boiling point of 155 degrees. DOT5 is a silicon-based fluid and is not compatible with some manufacturers' brake systems and must never be mixed with other fluids. DOT 5.1 has a full synthetic base, resulting in a much higher wet and dry boiling point. Viscosity refers to a liquid's resistance to flow and is subject to changes with temperature. It decreases as the liquid is heated and increases as it cools. For reliable, consistent braking, brake fluid must maintain a constant viscosity across a wide range of temperatures, ranging from a very low -75 degrees Celsius to a very high temperature of 260 degrees Celsius. This is especially important in systems with anti-lock braking, traction and stability control systems. Brake fluid is designed to be non-corrosive to the metal components inside the brake system. The fluid must also protect against corrosion and rust from any moisture that has entered the system. For this reason, inhibitors are added to the fluid during production. If mixing fluids from different manufacturers, or even by adding new fluid to a system, we are potentially mixing water-absorbed fluid with new product, lowering its boiling point and reducing the lifespan of the newer fluid. Glycol-based and silicon fluid should never be mixed together. There are several different inspections that can be performed to the brake fluid on a vehicle. They include a visual inspection, contamination test, conductivity, copper content, and a boiling point test. Visually inspecting the brake fluid may help determine its condition. We can place some into a clean, transparent container and inspect it. If the fluid is dirty or separates into layers, it may be contaminated. Copper in minuscule quantities is an early sign of corrosion forming in the brake system. Special test strips are available to test the copper content of the fluid. The test strip is dipped into the brake fluid reservoir and will change colour depending on the condition of the fluid. We can then compare the test strip to a colour chart that indicates the level of contamination. Conductivity testers determine the moisture content by measuring the fluid's conductivity. Since brake fluids vary from formula to formula, this test does not present an accurate result unless the tester is calibrated to a new sample of brake fluid. Testers that measure boiling point are recommended by OEMs and brake fluid manufacturers, as it's the most accurate and reliable. Follow the tool manufacturer's procedure for testing the brake fluid. Always remove a sample of fluid for testing and never put the tool directly into the reservoir. Once finalised, compare the results to the manufacturer's minimum wet boiling point for that fluid. If the fluid does not meet this minimum standard, it must be changed. Again, always follow the manufacturer's procedures when performing this service. The vehicle brakes must always perform when required, and to ensure this happens, the brake fluid must be checked, tested, and replaced regularly. Thanks for watching.